Welcome to this OST2 lecture about file attestation using a TPM 2.0. File attestation is the process of providing evidence that a file is in a known state. And when we say known state, this typically refers to a good state, the state that we want the file to be in. The file could be a configuration for the software that your system is running. The file could be a license. The file could be just the user data, so we guarantee there has been no tampering. We can use it even against malware protection. Let's forget for a moment that we're talking about the TPM. We can verify the state of a file by computing the hash digest over its content and comparing it with the previous value over the same file. The TPM comes in the moment we need to build trustworthiness into that comparison. We'll have a signed digital report of the hash digest of the content of that file. To perform this, we have the command tpm2quote, and this command requires an attestation key, a specific signing key. This specific requirement comes from the fact that we'll be signing the data in the PCR, and the PCR, from the perspective of the TPM, is internal data. Therefore, we need to set sensitive data origin flag for our attestation key. This will allow the TPM to use that private key material to sign the data from the TPM. Naturally, we also need fixed TPM and fixed parent set, so the key cannot be duplicated and is bound to our TPM on that system. Let's take a closer look at the command request for tpm2quote. In the input data fields, we have a sign handle that points to the attestation key that we're going to use. This is the child signing key with the special properties that we just talked about. Then we have qualifying data field, which is extra data that can be added by the caller, by us. This can be additional nonce data for freshness, or it could be something else. I usually use it as something else to add additional information about the system. The qualifying data becomes part of the signed evidence later, so this is quite useful. InScheme tells us what is the signing scheme to be used by the TPM, and this usually is already specified in our key, but in case it is set to no, and this is the TPM underscore ALG underscore no define, then this command will look at that field here in scheme to determine what signature scheme should be used to perform the digital signature over the evidence. Last but definitely not least, we need to make sure that we are selecting the proper PCRs. The PCRs that will be part of the evidence. And this means the hash digest that will be included in the evidence. So we should have already done PCR extent before invoking tpm2quote. Here are the outputs of the tpm2quote command. We have a tpm2b attest structure and the digital signature over that structure, over the evidence. tpm2b attest is just the generic structure to receive the buffer of the evidence. To make sense of the evidence, we need to take a closer look what are the different unions defined in the structure specification of the TCG regarding the TPM. This is part 2 of the specification. Prepare yourself because this is a bit like Inception, and you'll see what I'm talking about in just a moment. The tpm2b attest has a set of fields that have a clear purpose. The magic field is the TPM generated value defined that tells us this data did originate from the TPM. And because the evidence is signed, if someone tries to tamper and just insert these bytes into an evidence, then the signature would not match. Then we have the type, which is quite important, as you'll see in a moment. The TPMI ST attest specifies what is the attestation being performed, and based on that, here the union later, the type-specific attestation information, will determine actually what kind of evidence information we have available to us. And this is where things get a bit complex. The other fields, qualified signer is just the qualified name of the signing key, the digest name. Extra data, remember the qualified data from the input? This is our user arbitrary data, what we provided as a caller when we invoke tpm2quote. Quoc info is valuable quoc information. I'll talk about that a bit later. And firmware version is the TPM version of its firmware. Useful for some checks depending on the use case. But let's focus on this TPMU attest field because this is where the PCR digest will be, and this is what we need to look closer at. Just remember, the TPM attestation type set here in parameter type TPMI-ST-attest defines later what union will be used to decode the attested data structure here. Here is the list of available TPM attestation operations. We have the TPM2 certify, which we can use for key attestation. We have the TPM2 quote. Additionally, get session audit digest, get common audit digest, which is relevant to audit sessions that we covered briefly in TC1101 and also in TC1102. Get time, which we mentioned in the previous lecture as a time attestation, very useful for monitoring, especially of networking. And then we have also certify creation, which is additional method of key attestation that we can perform. And last but not least, TPM2 NV certify that can help us prove the origin of data in the NVRAM of the TPM. Based on the attestation performed, we have different unions here that we'll use to decode the attested structure. This is why I said it will look a bit like Inception. Taking a closer look of the type for TPM2 quote, which is TPM-ST quote info, we are found ourselves with a TPMS quote info union structure. Now that we know our TPM attestation type, which is TPMS-ST quote info, we can directly look at the TPMS quote info structure. And because we are already several levels deep into the TPM2 quote response, here I've provided a brief overview where actually we are. From the TPM2 quote response, we looked at the quoted structure which holds the evidence data in raw format as a buffer. Then we looked at the attested structure, which again holds the evidence specific data, other from the magic value of the TPM, different from whatever the version of the TPM is, or from the extra data that we added as the caller to the TPM2 quote. And we are now looking at the TPMS quote info structure because the TPMS-ST quote info was set in the type field of our evidence. This is in essence the actual data that we requested the TPM to sign, the PCR digests. And of course, the accompanying data is important as well. But often people get a bit frustrated with the complexity of trying to get several layers and through several unions to reach to that data, but this is for a good purpose. We do need to have the evidence of the magic byte. We need to have the extra data option, also the nonce for freshness, and so on and so on. All of these components make the TPM attestation trustworthy. So here is the PCR data that we requested to be signed. We have a PCR selection in the PCR select parameter that specifies which PCR numbers, from what algorithm, is it SHA-256, is it SHA-384, and then we have the actual digests. This is additional overview of the process that we just described, that the evidence we receive from the TPM2 quote command resides in the quoted structure, and the signature is actually over that original TPM2B buffer. When we look closer at the data, we'll notice that there is an attested structure, and further we need to look at the proper union structure to retrieve and decode information that we care about, in this case, which are the PCR digests. An important detail is that when we select multiple PCRs, we will receive a composite digest of all the PCRs, concatenated digest of these PCRs. This is done for additional layer of security where different values of the PCRs cannot be reverse engineered and figured out, because although difficult with given sufficient amount of tries and depending on how many times we did PCR extend, we can try to brute force and reproduce how do we get the hash digest value. Of course, this is not an easy task and it's very time consuming, but because of that slight possibility, for TPM 2.0 it's chosen that multiple PCR selection results in a composite digest, and single value PCR will result in the single value digest being quoted. Now, there are interesting notes here to be read in the TCG specification that I've pointed in part 3 and part 1 related to this change from TPM 1.2 to TPM 2.0. Here is an overview of the different fields of the quoted data. I think one of the most important fields is the extra data because it gives us the option to add additional arbitrary data, nonce, and so on. Then, of course, we have the attested PCR select, PCR digest, the PCRs we requested to be signed. Then the firmware version of the TPM can matter as well because we have a signed report. So if this version differ in any way, we can be alerted of an unauthorized firmware update by any chance or something being off if that doesn't match what we already know about the system. Clock info is a very interesting field that because it is privacy sensitive, unless we're using an AK child signing key under the EK, it will be obfuscated. So we wouldn't be able to actually determine the values in this structure here. And we wouldn't be able to say what is the uptime of the TPM. If we use AK under the EK, then this will be human readable and we can determine how many milliseconds the TPM was uptime and so on and so on. So the magic value here is just an additional proof in the signed evidence that this is genuine data. And then the qualified name is also just for additional proof of the key that has been used. Last but not least, we have the type that helps us determine what is the attested data we have so we can parse it properly. Here is the ESAPI variant of TPM2 quote. The comment matches very closely the structures that we just talked about. First, we have the ESYS context, then we have a sign handle that points to a loaded and ready for use AK signing key. And remember, it has to have set the sensitive data origin property in order for the TPM2 quote to work and sign data in the PCRs. Then we have the 3 authorization slots, qualifying data, which is the arbitrary data that we provide. We have in scheme if our key by any chance doesn't have that defined in its key structure. PCR select, which is important to define what PCRs we want, the numbers and algorithms of those PCRs, because remember we have different PCR banks. Then what we would receive as a result is the quoted structure, which holds the evidence, and the signature holds the digital signature over this data. Do not forget to perform the digital signature verification. Sometimes focused on decoding and parsing the quoted structure, I've seen it happen so many times. It just people forget to do that. It just remains a to-do in the code somewhere, and it's an honest mistake. It happened to anyone. The good thing is that it usually happens during development time. Similar to how we approach the PCR operations, I recommend using the TPM2 tools to try and perform PCR operations together with the TPM2 quote. Then use our ESAPI template or use the solutions from the previous labs about PCR operations to build upon and add assigned evidence on top of the PCR operations you performed. I recommend using AK under the EK so you can also look at the clock info field. I think that would be interesting to you.